this class, we'll do the remaining LAQs of DeMoivre's theorem. So in the last class, we have covered 4 LAQs and now we are going to cover the remaining 4. Okay. So take the 5th LAQ. If n is a positive integer, show that p plus iq whole power 1 by n plus p minus iq whole power 1 by n is equal to 2 into p square plus q square whole power 1 by 2n cos 1 by n tan inverse of q by p. So let's start now. Like the same way how we have done first 2 questions, like we were taking the first bracket and we were converting into modulus amplitude form. So the same way we will proceed, okay? So let p plus iq is equal to r into cos theta plus I sin theta. So we are doing this way because we don't know what is p and what is q. So we are equating it to r into cos theta plus I sin theta. Now we are comparing real and imaginary parts. So we get p is equal to r cos theta and q is equal to r sin theta. Now if we are squaring and adding it, what do we get? P square plus q square is equal to r square we get. Because cos square theta plus sin square theta is 1. So r is equal to root over p square plus q square you get. So hence, now if I substitute this r value over here, so we get p is equal to r cos theta. So p is equal to root over p square plus q square cos theta. So we get cos theta value as p by root over p square plus q square. Now same way if I take q is equal to r sin theta. Now in the place of r I substitute root over p square plus q square sin theta. So we get sin theta is equal to q by root over p square plus q square. Now how do you get tan theta now? You got cos theta, you got sin theta. Tan theta is if I divide sin by cos, I get tan. So if I divide these two, denominators will get cancelled and you will get only q by p. Understood? Now after finding tan value, see we got tan theta is equal to q by p, right? So how do we get theta value? Tan inverse q by p. Okay. Now let us see how can we write p plus iq. P plus iq is r into cos theta plus I sin theta, right? We have assumed. Now we are substituting the values. That is r is root over p square plus q square into cos theta is how much? Let us write cos theta plus I sin theta only. Now similarly, we can write p minus iq as root over p square plus q square into cos theta minus I sin theta. Okay. So now let us take LHS. What is LHS? P plus iq whole power 1 by n plus p minus iq whole power 1 by n. So that is, now what is p plus iq value? Root over p square plus q square into cos theta plus I sin theta whole power n. We are raising the bracket to the power n. Now the same way, what is p minus iq? Root over p square plus q square into cos theta minus I sin theta raised to the power 1 by n. Okay. So now you can see, we can write this as p square plus q square whole power root. If I remove the root, I can take power 1 by 2. Now I am applying the DeMoivre's theorem. So I am applying this power also. So you will get power 1 by n, it will become 1 by 2n. Now for the second bracket, we are taking DeMoivre's theorem. So cos 1 by n into theta plus I sine 1 by n into theta. Okay. Plus, now coming to the second bracket. So p square plus q square whole power 1 by 2n. This we can put it in bracket. Into cos 1 by n theta minus I sine 1 by n theta. If I take p square plus q square whole power 1 by 2n common, we get cos theta by n plus I sine theta by n plus cos theta by n minus I sine theta by n. I sine theta by n minus I sine theta by n get cancelled. That is p square plus q square whole power 1 by 2n into cos theta by n plus cos theta by n is 2 cos theta by n. Now we can, this 2 we can write outside. P square plus q square whole power 1 by 2n cos. Can I write theta by n as 1 by n into theta? So 1 by n, what is theta value from here? Tan inverse q by p. So that is tan inverse q by p. Understood? So this is RHS. And this is LHS. So you finally got LHS is equal to RHS. Now take the next question. This is another model, but very, very important. Question number 6. If cos alpha plus cos beta plus cos gamma is equal to 0, and that is equal to sin alpha plus sin beta plus sin gamma, then show that first bit cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos alpha plus beta plus gamma. Second bit you need to prove is sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 sin alpha plus beta plus gamma. Number 3, cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha is equal to 0. So let's begin. First, it is given, we'll write what is given to us. So what is given to us? Cos alpha plus cos beta plus cos gamma is equal to 0. And that is equal to sin alpha plus sin beta plus sin gamma. Now let us say A is equal to cos alpha plus I sin alpha. B is equal to cos beta plus I sin beta. C is equal to cos gamma plus I sin gamma. First let us take A plus B plus C. So if you add these three, can I write cos alpha plus cos beta plus cos gamma plus from these three if I take I common, sin alpha plus sin beta plus sin gamma. But from the given it is seen that cos alpha plus cos beta plus cos gamma is 0. And sine alpha plus sine beta plus sine gamma is also 0. So that is 0, which means you got a plus b plus c is equal to 0. So we know from algebra, whenever a plus b plus c is 0, which implies a cube plus b cube plus c cube is equal to 3abc. We have a condition we have studied in 8th or 9th class, that whenever a plus b plus c is 0, we can write a cube plus b cube plus c cube as 3abc. Now we have to substitute in the place of a, b and c these values: cos alpha plus I sin alpha, cos beta plus I sin beta, cos gamma plus I sin gamma. Now let us substitute. So cos alpha plus I sin alpha whole cube plus cos beta plus I sin beta whole cube plus cos gamma plus I sin gamma whole cube is equal to 3abc, no? So we write 3 into a is cos alpha plus I sin alpha, b is cos beta plus I sin beta, and c is cos gamma plus I sin gamma. Now for the left hand side, for each bracket we apply DeMoivre's theorem. So that is cos 3 alpha plus I sin 3 alpha plus cos 3 beta plus I sin 3 beta plus cos 3 gamma plus I sin 3 gamma is equal to 3 into, see, we know that cos theta plus I sin theta can be written as cis theta. So this is cis alpha, second bracket is cis beta, third bracket is cis gamma. But from cis properties, we know that cis A into B is cis A plus B. So we can write this as 3 cis alpha plus beta plus gamma. We are using cis properties here. So what did we get? Now left hand side, what I am doing is I am separating cos and sine terms. So from here, here and here, I will take cos terms. So cos 3 alpha plus cos 3 beta plus cos 3 gamma. Now from the second term in each bracket, I will take I common. So we will get sin 3 alpha plus sin 3 beta plus sin 3 gamma. Right hand side, we got 3 cis theta, no? Now cis theta, again we can write cos theta plus I sin theta. So 3 into cos alpha plus beta plus gamma plus I sin alpha plus beta plus gamma. Okay. So now again I copy the left hand side as it is. Cos 3 alpha plus cos 3 beta plus cos 3 gamma plus I into sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to, now I multiply 3 inside, 3 into this, 3 into this. So 3 cos alpha plus beta plus gamma plus I into 3 sin alpha plus beta plus gamma. Now comparing real and imaginary parts. So if you compare real and imaginary parts, you will get cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos alpha plus beta plus gamma. And if I compare imaginary parts, we will get sin 3 alpha plus sin 3 beta plus sin 3 gamma is equal to 3 sin alpha plus beta plus gamma. With this, first bit is proved. And with this, second bit is proved. So first and second bit is proved till here. Got it? Now we shall prove the third bit. What is the third bit we have to prove? Cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha is equal to 0 we need to prove. So let us take A as cos alpha plus I sin alpha, B as cos beta plus I sin beta, C as cos gamma plus I sin gamma. So if A is cos alpha plus I sin alpha, then 1 by A will be cos alpha minus I sin alpha. It is the conjugate. Then 1 by B will be cos beta minus I sin beta. Then 1 by C will be cos gamma minus I sin gamma. Now let us add them. 1 by A plus 1 by B plus 1 by C. That is cos alpha minus I sin alpha plus cos beta minus I sin beta plus cos gamma minus I sin gamma. Now I am grouping them, cos terms in one bracket. Minus I if I take common, we get sin alpha plus sin beta plus sin gamma. But in the question it is given that cos alpha plus cos beta plus cos gamma is 0. And sin alpha plus sin beta plus sin gamma is also 0. So that is 0. Now left hand side I will take LCM. So we will get AB plus BC plus CA by ABC. If I take ABC to the other side, it becomes AB plus BC plus CA is equal to 0. Now again I will apply the values ABC what we have assumed in the beginning. So that is cos alpha plus I sin alpha into cos beta plus I sin beta plus cos beta plus I sin beta into cos gamma plus I sin gamma plus cos gamma plus I sin gamma into cos alpha plus I sin alpha. That is equal to 0. Now the first term is cis alpha. Can I write cis alpha? Second bracket, can I write cis beta? The same way we are changing the brackets. So this is cis beta into cis gamma plus cis gamma into cis alpha is equal to 0. Now let's see how can we write it. So cis alpha into cis beta we can write cis alpha plus beta. Cis beta into cis gamma we can write cis beta plus gamma. And cis gamma into cis alpha we can write cis gamma plus alpha. That is equal to 0. Now cis theta we can write it as cos theta plus I sin theta, right? So cis alpha plus beta I can write cos alpha plus beta plus I sin alpha plus beta plus cos beta plus gamma plus I sin beta plus gamma plus cos gamma plus alpha plus I sin gamma plus alpha. Now I group again cos terms and sin terms. So I write cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha in one bracket. Plus I if I take common, sin alpha plus beta plus sin beta plus gamma plus sin gamma plus alpha is equal to, now see this 0 I can write 0 plus I into 0, no, it won't make any difference. Now we compare real and imaginary parts. We compare only real parts because they are asking us to prove only cos. Look at the question. In the third bit, they are asking us to prove only cos. So if we compare only real parts, third bit will be proved. Okay, so cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha is equal to 0. Hence proved. Take another LAQ now. Same model. Question number 7. If cos alpha plus cos beta plus cos gamma is equal to 0 and that is equal to sin alpha plus sin beta plus sin gamma, then prove that cos square alpha plus cos square beta plus cos square gamma is equal to 3 by 2 and that is equal to sin square alpha plus sin square beta plus sin square gamma. The same way, let us take A is equal to cos alpha plus I sin alpha, B is equal to cos beta plus I sin beta, C is equal to cos gamma plus I sin gamma. So now let us find A plus B plus C, that is cos alpha plus I sin alpha plus cos beta plus I sin beta plus cos gamma plus I sin gamma. Now we are separating cos and sin. So cos alpha plus cos beta plus cos gamma, we are writing in one single bracket. And from these three terms, I am taking I common. So we get sin alpha plus sin beta plus sin gamma. But from the question, we know that cos alpha plus cos beta plus cos gamma is 0 and sin alpha plus sin beta plus sin gamma is 0. That is equal to 0. So you got A plus B plus C as 0. Now after getting A plus B plus C is equal to 0, we will take 1 by A plus 1 by B plus 1 by C. So in the last problem, we have taken 1 by A, 1 by B, 1 by C, no? If A is cos alpha plus I sin alpha, then 1 by A is cos alpha minus I sin alpha. The same way 1 by B is cos beta minus I sin beta. 1 by C is cos gamma minus I sin gamma. Again we are separating cos and sin. So cos alpha plus cos beta plus cos gamma in one bracket minus I into sin alpha plus sin beta plus sin gamma. But from the question we know that the first bracket is also 0 and the second bracket is also 0. So we got 0. Now on the left hand side, if I take LCM, we get AB plus BC plus CA by ABC. Now if we cross multiply, we get AB plus BC plus CA is equal to 0. Okay, we got that is equal to 0. Now let us keep this aside. Now we will take A plus B plus C whole square. What is the formula for A plus B plus C whole square? A square plus B square plus C square plus 2 into AB plus BC plus CA. But just now we got AB plus BC plus C as 0. So we take this as A square plus B square plus C square plus 2 into 0. And in the beginning we got A plus B plus C also as 0. So left hand side also I can take 0. 0 square is 0 because A plus B plus C is 0. Now what can I write? A square plus B square plus C square is equal to 0. Now I will substitute the values of ABC. What is ABC? We have taken cos alpha plus I sin alpha whole square plus cos beta plus I sin beta whole square plus cos gamma plus I sin gamma whole square is equal to 0. Now we apply DeMoivre's theorem. What is DeMoivre's theorem? Cos theta plus I sin theta whole power n can be written as cos n theta plus I sin n theta. So this is cos 2 alpha plus I sin 2 alpha plus cos 2 beta plus I sin 2 beta plus cos 2 gamma plus I sin 2 gamma is equal to 0. Now we will separate cos and sin terms. Okay. So cos 2 alpha plus cos 2 beta plus cos 2 gamma. We group in one bracket, then we take I common. So if we take I common, we get sin 2 alpha plus sin 2 beta plus sin 2 gamma. That is equal to, we got it as 0, but 0 we can write it as 0 plus I into 0. We are converting it in A plus IB form. Now we will compare only real parts. Okay. So cos 2 alpha plus cos 2 beta plus cos 2 gamma is 0. We know that cos 2 alpha from trigonometry, we know that cos 2 alpha formula is 2 cos square alpha minus 1. So the same way 2 cos square alpha minus 1 plus 2 cos square beta minus 1 plus 2 cos square gamma minus 1. From these three terms, if you take 2 common, then cos square alpha plus cos square beta plus cos square gamma. Minus 1 minus 1 minus 1 becomes minus 3. Now 2 into cos square alpha plus cos square beta plus cos square gamma is equal to 3. If I take this minus 3 that side. Now I will take this 2 to the other side. So we get cos square alpha plus cos square beta plus cos square gamma is equal to 3 by 2. First part of the question is proved. Okay. Now let's take this as equation number 1. Now cos square alpha, can I write 1 minus sin square alpha from trigonometry? Then cos square beta, can I write 1 minus sin square beta? And cos square gamma, can I write 1 minus cos square gamma is 3 by 2. Okay. Now if I take like 1 plus 1 plus 1 is 3. If I take minus common, we get sin square alpha plus sin square beta plus sin square gamma is equal to 3 by 2. Okay. So if I take this term, this bracket, if I take that side, it will become positive. And 3 by 2, if I take this side, we will get sin square alpha plus sin square beta plus sin square gamma is equal to, already you have a 3 here. This 3 by 2, if I bring this side, it will become minus 3 by 2. 2 3s are 6. 6 minus 3 is 3 by 2. So that is 3 by 2. Whose value is this? Sin square alpha plus sin square beta plus sin square gamma is 3 by 2. Let's say equation number 2. Now look at the question. Did we prove both of them? So from 1 and 2, the result is proved. I hope you understand this. Now take the next question. The last LAQ. Show that one of the values of 1 plus sin pi by 8 plus I cos pi by 8 by 1 plus sin pi by 8 minus I cos pi by 8 whole power 8 by 3 is minus 1. So first let us take only the bracket. So the bracket is 1 plus sin pi by 8 plus I cos pi by 8 by 1 plus sin pi by 8 minus I cos pi by 8. Now from trigonometry we know that, so before using the trigonometry concept, we will take this concept like sin theta can be written as cos 90 minus theta. And cos theta can be written as sin 90 minus theta. Okay. So this, instead of sin pi by 8, I will write cos 90 minus pi by 8 plus I sin 90 minus pi by 8. Why I am doing like this? Because always we know that what is this? Cos theta plus I sin theta. But it is sin theta plus I cos theta form. It is reverse given. So we have to correct it. Like we need to put it in cos theta plus I sin theta form. That's why we are representing in this way. Understood? To change sin to cos, we are writing cos as 90 minus theta and sin as 90 minus theta. Now the same way we have to write the denominator. Sin theta, we will write it as cos 90 minus theta minus I sin 90 minus theta. Now next step what we have to do is, what is this pi by 2 minus pi by 8? We need to find out. So let's take LCM and find out what is that. So LCM is 8. So 4 pi minus pi is 3 pi by 8. So we can rewrite it as 1 plus cos 3 pi by 8 plus I sin 3 pi by 8 by 1 plus cos 3 pi by 8 minus I sin 3 pi by 8. Now we use one more concept of trigonometry, that is, see, 1 plus cos theta can be written as 2 cos square theta by 2, and sin theta can be written as 2 sin theta by 2 cos theta by 2. This concept I am using now. So 1 plus cos theta, I can write 2 cos square theta by 2, no? In the place of theta, we write 3 pi by 8. So 2 cos square 3 pi by 8. Again by 2, no? So that becomes into 2. That 2 comes in the denominator. Plus I into 2 sin 3 pi by 8 into 2 cos 3 pi by 8 into 2. By the same thing in the denominator. 2 cos square 3 pi by 8 into 2 minus I into 2 sin 3 pi by 8 into 2 cos 3 pi by 8 into 2. Is it clear to you? Now you can see how can we write it. 2 cos square 3 pi by 16 plus I into 2 sin 3 pi by 16 cos 3 pi by 16 by 2 cos square 3 pi by 16 minus I into 2 sin 3 pi by 16 cos 3 pi by 16. If I take 2 cos 3 pi by 16 common, we will get cos 3 pi by 16 plus I into sin 3 pi by 16. In the denominator also the same way. We take 2 cos 3 pi by 16 common. So you get cos 3 pi by 16 minus I into sin 3 pi by 16. Now we are cancelling it. Now whose value did we find now? 1 plus sin pi by 8 plus I cos pi by 8 by 1 plus sin pi by 8 minus I cos pi by 8 value we found. That is cos 3 pi by 16 plus I sin 3 pi by 16 by cos 3 pi by 16 minus I sin 3 pi by 16. Now in the question it is raised to the power 8 by 3. So let us raise this entire bracket to the power 8 by 3. So now we are separating numerator and denominator. Shall I apply DeMoivre's theorem directly? So we will get cos 8 by 3 into 3 pi by 16 plus I sin 8 by 3 into 3 pi by 16. By denominator also I am applying DeMoivre's theorem. cos 8 pi by 3 into 3 pi by 16 plus I sin 8 by 3 into 3 pi by 16. 3 3 cancel, 8 ones are 8 twos are. 3 3 cancel, 8 ones are 8 twos are. Same here also. So what are we left over with? Cos pi by 2 plus I sin pi by 2 by cos pi by 2. This is minus. So minus I sin pi by 2. Now cos 90 is 0. Sin 90 is 1. Cos 90 is 0. Sin 90 is 1. Okay, so this is I by minus I. I cancel, answer is minus 1. Hence proved.